All right, so welcome to IME 145. Let me get my Mastercam banner in the background right there, right? Because what we're going to be doing today is I'm going to be showing you how to operate Mastercam 2021 from start to finish, really. So we're going to make a very simple part together, getting you kind of oriented with how Mastercam 2021 works. And then you're going to be given your second CNC project for our IME 335 class, which is to create the CAM program, or actually you got to create the model first, but you got to create the CAM program to make our CNC business card holder. So we're going to do that together. But today we're going to pretty much program the part that you see right here. Now I'm going to screen share. Give me 1 second. So looking at this, we're going to program this simple part. Up on Canvas, I gave you the solid model in SolidWorks if you wanted to try to import it yourself. And then also the engineering drawing as well. For this part. You always need a drawing to kind of see your tolerances, right? What type of depths you need to go ahead and machine off the part, and just kind of give you an overall part size. So just wanted to let you know, project number 1's machining deadline. Homework number assignment 4 is due today. You have to get your code approved out by today if you want that 20 points for that out of the 60 on that homework assignment. In fact, let me just jump over to Canvas real quick to show you, right? I couldn't do math, so I changed the math to make it work with the points down here. But you were supposed to manually create that manually written program, which is worth 5 points for turning that in, and a screenshot of it simulated, that's 10 points. And then 10 points for the actual setup sheet right there. So there's 20 points there. And then if you didn't get your code reviewed by today, if you've already ran your part, you don't have to worry about this, right? But that would have been the 20 points. And then the PDF of the setup sheet that you wrote was going to be due by today by the beginning class today. But you can run your part all the way up into 3 p.m. tomorrow. So some of you may have missed the setup sheet deadline. You want to, though, make sure that you get your part ran by tomorrow, because tomorrow at 3 o'clock, I'm basically telling my lab tech to run out the rest of the blanks that are there with my program. And that way you have an op 1 done, and you can then go on to op 2 and no problems, but you're not getting credit because you didn't run it yourself. Does that make sense, everybody? So just wanted to make sure that everybody was on the same page there for our class. So that was just our machining deadline right there for the first project, the manually written code. Now we're going to start off with CAD/CAM programming today. It's the first time a lot of you have seen CAD/CAM programming, right? Or have experienced it. First time some of you have had Mastercam as well. We all have that 2021 Home Learning Edition. But I kind of want to just kind of give you an overview of it real quick. And then we're going to get into actually Mastercam 2021, seeing how it actually works and how to set the work coordinate systems, how to create tool paths, and so forth. Now, really the CAD/CAM programming process, it's got 3 major components. And we talked about this a little bit during the midterm exam review, if you remember, right? We have the first component, which is going to be our design. And that's going to be the CAD. So, right, that's your geometry. So we need some sort of CAD model or some sort of wireframe model, a surface model, some sort of geometry to go ahead and program off of, the part geometry. Now, along with that design or the CAD comes like the work coordinate system, setting up where your datums are going to be for that program, or where the XYZ 0 is going to be. And where do we always want to go ahead and put that XYZ 0? Where's a good point in the machine? Anybody?
Back left bottom.
So why would you put it back there though? So so you just pick the back left and the bottom, right? Why'd you?
Well, it does depend on your setup. Left or right really doesn't matter.
Right, but it has to be a location, right? So we want to base a non-movable location in that machine.
Yeah.
The reason we pick back is because the Kurt Bice we were using has that fixed jaw in the back, right?
Yep.
And the bottom, it never changes wherever we put the part down on the datum. So we've always had our Z0s at the bottom here for this shop. Some shops put them other places, just depends. And then you're right, Kieran, right and left doesn't really matter, right? I always just put mine on the left. Then everything, most of the part stuff's on the right side, so it's in the positive X's. So that's going to be our CAD, right? Or the CAD part of CAD/CAM programming, figuring out the geometry and setting up the work coordinate system. Then we have something called the tool paths. The tool paths are going to be the CAM portion of it, where we create centerline location data for that part. Then last but not least, we have that post processor, which creates all of the G code for you, right? It takes all the centerline location data based off of where the CAD model is and the 0 points, and it makes a readable G&M code for your specific CNC machine brand. So each step has input data and output data. And really what we're going to do is just going to show you some things in Mastercam that you may or may not have to do, but I could actually program this part off of a wireframe model. I could have just a 2D wireframe surface model of this part. I didn't even need 3D wireframe. And I could totally make this part from start to finish with just 2D stuff. Just realize that. But back in my day, back when I was like your age and learning this stuff, that's what we had. We had a lot of the stuff, basic stuff and parts. We would just have a 2D wireframe that we would program around. A lot of parts I've made of isn't just 2D, one plane, and I can make a 3D part off that. Now, for this CAD/CAM programming process, so we're going to bring in our SolidWorks model. So that's what we're going to end up doing. But I was going to show you, I don't really draw too much in Mastercam. I just bring in models and then program off models. Some things I'll draw maybe are boundary chains and stuff like that, and draw some other stuff for multi-axis stuff. But for right now, we're going to bring in the CAD model into the system. And basically, we're going to use that CAD model to basically describe our parts features, right? And go ahead and set that work coordinate system. Now, when we create the CAM portion of this, the CAM portion is just centerline location data. So when you see all these blue lines and yellow lines get created from Mastercam on your part, that's the center line of the tool, just like you did in your first CNC project with your hand programming, right? Created those cutter path location drawings and programmed to the center of that tool. So that's all the CAM system's doing. It's mathematically calculating where it needs to go in the computer and makes that center line location data based off what you have filled out in the cut control menus. So you're going to go through a series of menus where you tell it the RPM, the feed rate, the depth of cut, the step over, and so forth for that tool path. And then the computer will go ahead and create that centerline location data. And the last step from that after the CAD/CAM part is that post-processor. So once we're all happy with all of our CAM data, we're going to then go ahead and pick the appropriate post, Haas, right? That's what we have in our labs, all Haas machines, good quality American-made machines. And we'll have that code generated at that point. So that's what we got going for us today is we're going to learn the CAD/CAM process in Mastercam 2021. So I do have the PowerPoint that kind of steps you through the entire thing, but I'm not going to probably come back to it. Sound good, everybody? I do. It goes through exactly what I'm doing in my demo. So we're going to end up actually right here when we're all done starting our business card holder, right? Or basically starting our business card holder. So realize that I'm going to be at slide 49 by the end of this demo, but the slides will go through exactly step by step what we need to do. But before we get to that, let's look at the engineering drawing. Sound good? So this is the engineering drawing. This part, it's a symmetrical part. So I just dimensioned everything off the center, kind of right there, right? Just real simple part. Or the purpose isn't the part. The purpose of this exercise or today, this lecture, is to show you how Mastercam works. So part of CNC programming, if you remember, was figuring out what tools we need, right? So if you wanted to program and run this part, I have a bunch of this stock, by the way. So if you wanted to actually do that, I have some 4x4 stock that just some coupons, and you could program and really run it if you really wanted to try it out. But what we're going to run is we're going to run basically our 3-inch carbide insert face mill. We're going to run a 1/2-inch carbide end mill. I actually have a 3-flute one now, so it changed to 3-flute. Let me go ahead and clear that real quick. And we have a 1/4-inch basically jobber drill we're going to use to go ahead and just basically drill those holes right there, those 5 1/4-inch holes. So real simple, face milling, drilling, contouring, and pocketing in Mastercam. That's what we're going to learn about today. Does everybody understand how this works? Or how this part looks so far and what we're doing? What would you start off with first if we know we have a face mill? You start. Yeah, so Kevin goes like this. So we're going to go ahead and we're going to go you see that 490 on the drawing? We're going to pretend we have 1/2-inch we're going to have 1/2-inch stock. We're going to take 10 thou right off the top, right? We're going to face mill that. Then we can either contour it or pocket it afterwards. I'm just going to go in order of tools for now. But I would say we just contour the outside and then we pocket the inside. Sound good? So we'll come around the outside, we'll pocket the inside, and then we'll drill 5 holes and we'll post-process it. So with that in mind, I'm going to go ahead, let me get rid of my drawing tool, And I'm going to just skip all the way down to basically slide 49, right when we're done. So we're going to get to that point now in Mastercam, but I'm not going to jump back to slides. So here, when I open up Mastercam for the first time, this is what I've got. So I've got a screen right here, and my models will be in here, or my geometry. When I create tool paths, I'll start to create the different tool paths in this window right here. So I know you're all used to SolidWorks because that's what we model in this class, right? So instead of having a feature design tree, you kind of have like major tabs over here that are important. And I only have the 3 major tabs that are important for me and for us programming right now. But I wanted to show you real quick up here at the view screen. They're called managers. They're not tabs. Does everybody see under view and managers, I could actually add solids, multi-threading if I really wanted to. We don't want to do that one right now. I don't want solids, but this is how you add your managers. So I guarantee one of you are going to end up like having no managers, or you're not going to have any managers down there, or you might just have levels or something. You got to go to your view and just add toolpaths, levels, and planes. That's the 3 important ones that we care about for simple programming for right now. Does that sound good, everybody? So we've got toolpaths, levels, and planes. Questions so far, anybody? No. Cool. So literally, I just wanted to show you that. That's just kind of a view. If you have issues with views, go to your view and you can do fit. You can zoom. I like rollerball mice, so I can just zoom back and forth with my rollerball. That's my biggest fan for zooming in and out. And then I use fit quite a bit. Now, what I'm going to do, now that I've opened up the program, what do you think we need to do? Anybody?
You to bring our model in.
We need to bring our model in. Awesome. Let's do that. So we're going to go basically file, and we're going to open up a SolidWorks model. So you have this model somewhere up on Canvas. So I'm going to go to open. Ooh, I don't know where I put mine. So let me go. I didn't want that one. I thought that was it actually. So I've deleted a lot of my files, which isn't good. So we're going to go file new. I deleted a bunch of my stuff. My computer was filling up. So we're going to go file open. Sorry. I'm going to go ahead. I'm going to go find where that's going to be. So I'll hit browse. And I'm going to guess that we're in desktop, Cal Poly, spring 2021, 335. I'm hoping it's in week 5. Ooh, and then right now, does everybody see how it can't find SolidWorks parts at the moment? Does everybody see that? Do you know why? Down here under the file type, it's looking for only Mastercam files. So if I'm going to open up a SolidWorks file in Mastercam, I come down here, I go to SolidWorks and Mastercam demo. There it is. I luckily had it, I found it. So you just got to pick your type of file and then you press open. Fair enough? Is everybody good with that? See how that worked? Now, what I'm going to do here is I'm going to, now that I have my model in here, what do you think is a good step next? What should we tell the system about? We're still in the geometry stage, technically, for CAD/CAM programming. What should I tell it?
Verify your axes are where you want them.
Yeah, so I want to set up my work coordinate system, right? Does that make sense, everybody? So my work coordinate system is your G54 in the CNC machine. So I'm going to go ahead and I'm going to go to my planes right here. Does everybody see my plane manager? So that's the planes tab. This is going to set up does everybody see this says WCS right here? That's work coordinate system. Well, right now it's all based off the right-hand rule, right? So if you go like this to the CNC machine when you're standing in front of it and your thumb is in the positive X, your pointer finger is positive Y, your middle finger is positive Z, that's how the part's going to sit in the machine. So what Kieran said earlier, it's the top, or it's the bottom, or it's the back, left, bottom, right? That's where you're saying that the 0 point was. Does everybody see that? So right now, that's where the 0 point is. Does everybody see that? Because it's our WCS. When I click on it right there, that's where I'm going to be programming off of. Does that make sense, everybody? Well, let's say you didn't want to program there. You could go ahead and you could actually create new work coordinate systems from like geometry, a solid face. You could do a dynamic one. So you can move your work coordinate system around wherever you want. Does that make sense so far? One way I like to do it, I'll just show you. I like to right click. I like to duplicate them. So it's because I can't move the world around, right? I can move stuff that I have that's different. So I duplicate it. And what I do is I rename it. So I'll rename it and I'll call it my G54. I won't call it my G. I'll just call it G54 WCS. Does that sound good, everybody? So it doesn't become your WCS until you have WCS show up. So if I hit this equal, it becomes my WCS. Now I did that so I could show you that I can move it around. I could put it right here, the top center. Did everybody see that? So that's my one WCS. Check this out. I hit this button right here. It's just this button. Maybe I want it in this corner up here. Does that make sense? Well, that's not like where we want it, right? But that makes sense how you can move it around, right, everybody? So where do you want to put it for right now? I have a really good answer for this. You know why? We're not cutting the outside of this part, are we? We're not cutting the 4x4 side of this part, right? So if I have a 4x4 blank and I want it to be symmetrical, where would a good place be to put the 0 point on this part?
On the center line?
Yeah, I'd put it right in the center. Thanks, Ryan. So I'd put it like, I'd hit this button. I'd probably put it right here in my part. And I grab I'd grab the probe on the Haas. So that OMP 40 probe, and I could probe basically left, right, and then find the center, and then up and down in the Y and find the center right there. So we're gonna just set it up as a center right now. Sound good for you? Cool. So I made that my center. Now when I press F9, everybody, on and off. You see that? It toggles your axes. So what I have is the gray one is my world axis. So that's the world that I modeled it in Mastercam. What do you think the green one is?
WCS.
Yes, right? Did you see that? So that's where my XYZ0 is. Do you have any questions? That's F9 to toggle that on and off. Pretty cool, right?
What was the button that you clicked plus up in the top of planes to set that origin point?
No, I just was showing you other ones.
Oh, okay.
What I actually did is I just I can duplicate them at any time.
Oh, gotcha. Okay. You just duplicated it and then renamed it.
I duplicated and renamed it because if you look at this, I just deleted the one I just renamed because I can't move the world. Remember that. You cannot move the world, right? So these are the world. Does everybody see how it's grayed out and I can't move it around down here? You see that? So literally I had to duplicate it so I could then have this available for me to move it. Sound good?
Thank you. Yeah.
You're welcome. So my work offset, if I pick automatic, what do you think it posts for my G code? What's the default G code for our work offset?
G54.
Yeah, so I could go to manual, I could put like a number in there and it starts counting upwards. Does that make sense off of G54? But we're gonna stay with automatic for right now. What questions do you have about the planes menu? So if you remember, we did a little HSM works on Tuesday, right? So the planes are like the jobs, or like setting up the work coordinate system in the job menu in that one. You have any questions? No, we're good. So we're basically programming now off of the center of the part. We have our XYZ0 set. Now I'm gonna go over to, I could show you levels. I'm gonna show you some stuff later with levels, just because. Now I could come over here, whoops, not to that, to my tool paths. So once we have set up where brought in our geometry, we showed the computer exactly where we want to set up the XYZ0 on the CNC machine based off of our fixture, right? Where we're gonna have a repeatable location. This program, we're gonna probe it every single time on this part. That's what we're gonna say. We're gonna probe the middle of the part. So we're not really worried about having basically a fixed location for this home one, because we put it in the vise and it'll actually end up probing it. Questions? No? So tool paths now, there's nothing here to create tool paths. What you actually have to do is you have to go over here to this machine tab, everybody. Now you have to set up what type of machine you want to make tool paths for on this part. Does this look like a lathe part? No. So we're not going to pick lathe. We're going to pick wire EDM. No. How about a router? We could probably make that on a router, but no, we're not going to make that on a router. We're going to make it on a mill. Now, when you click on this down arrow on yours, you're going to have nothing right here. Do you see how you don't have a mill default? You need to go to manage list and you need to pick mill default. So yours looks like this now, doesn't it? Is everybody good? You get two, by default, you get two generic mill posts that work fine on the Haas for right now. When we get into multi-axis stuff, I'll give you 4 and 5 axis Haas posts. But for right now, the mill default will work fine. Now there's 2 versions of the mill default. Does anybody take a guess what the 2 versions are?
One is in millimeters.
Oh yeah, how'd you figure that out, Thomas?
It says mm.
Yeah, very good. So which one are we not gonna pick? The one that says MM, right? So I was trying to get a response from you. So what we're gonna do is we're gonna take this mill default and we're gonna hit add. Does that sound good, everybody? And I hit check mark. Now it should just show up right here as the mill default to use. So what you do is you add all the machines that you want to have normally. Does that make sense? That you normally have in your shop right there to write programs for. So we have mill default, select it, and you should get something that says machine group 1 right here. So now we have basically a setup, or like in the HSM, we basically have like a job to go ahead and make this. How are we doing? Good. So I like to go ahead and I like to go to groups. I like to go to rename. I'm going to call it CNC op number 1. I like to name everything. So again, you just right click groups and rename that group. I'm just going to call it CNC op 1. That's all we have here is one CNC op. So we're just going to have that one set up. You got any questions for me, everybody? So now at this point, I like to just I'll go down here into the properties. Now with Mastercam, there's 2 different ways to do stock. There's just a stock here in the stock setup, and then there's this really cool stock model. I'll show you stock model later. Today's the beginning day. Sound good? So we're just going to set up regular generic stock and not worry about this stock model here. So we're going to just do a stock setup right here. So when you click on this, let me just do it again. When you click on this stock setup, you get these properties to add virtual stock to your part. Is that making sense, everybody? So when I look at it, check this out. I can pick where the home location is. Does that make sense? So mine's in the center. It's off of G54 WCS. It's going to be rectangular. And let me go right here. And what I'm going to do is my stock is 0.5 thick. It is 4 by 4. Am I making sense? Now I believe it's 0, 0 off the G54 home location because of where this is. Is that making sense? So when I hit check mark, and I go to stock display, I put mine too low. Let me show you this. You know why? My Z, does everybody see? This is the top right here. Does everybody see that? That's the middle top. Mine's actually the middle bottom, right? So I got to put a 0.5 Z in it right there. Does that make sense, everybody? Because it's point. And then if you want to show it, click solid right here. And then when you hit check mark, now I've got stock over my part, right? Does that make sense though, why it was below at first? So when I go to stock setup, the reason it was below is because these coordinates are off of the WCS XYZ0. And I'm at the top of my stock. It doesn't have a where you can go to the bottom center. Cool? But if I accidentally clicked over here, watch what's going to happen. Whoops, it goes off the 0, 0 point, right? So I just wanted to kind of show you how that works. So we have just built virtual stock. Do you agree? Do you have any questions on that? Are you keeping up, those of you that are following along?
How did you view it? Like, how did you display the
Yeah,
stock?
so there's 2 ways to view it. If you have stock up here, you could shade it back and forth or display it. Or in stock right here, there's the display button right here. So they both do the same thing. Cool. And then there's wireframe, which I actually don't like wireframe. It just kind of shows you that. I like the shaded, but to each his own, right? So I like it shaded. That's just me. We good there? Cool. So now I'm just about ready to make tool paths, right? So I could do about this two different ways. I could build my tools first and then make the tool paths, or I could put my tools into my tool paths as I build them. What do you think? What do we want to do? I don't care.
Build them as you go.
All right, Max, we're going to build them as we go because you told me that first. Sound good? So what we're going to do is we're going to start creating tool paths. Our tool paths are based off of the geometry of our part. So right now, we're going to do 2-axis tool paths right now. 2-axis tool paths can run off of wireframe or edge geometry. So I don't need surfaces to show to drive 2-axis tool paths. So the most popular ones are going to be face milling. So we got face, we've got contour, we've got pocket, and then we've got drill. So those are the 4 most popular ones we're going to learn about today. We're going to learn about all of them as we progress through the class. Sound good? So today we're going to first start off with facing, because that's what you told me. Kevin went like this, face 10 thou off the top. So that's what we're going to do. So I'm going to click on face. Now, read this right now. If I go ahead and I could chain the part of the face I wanted to go ahead and machine, it'll also pick it for me, but really the face I want to machine is down there. All I'm doing is showing it the outside profile of my stock here. Even though it's the bottom of the stock, that doesn't matter right now. I'm showing it the geometry of what I'd want to face. Does everybody understand that? So how I did that, let me show you some selections here. So if I press the Ghostbuster symbol, well, you're probably too young for that. But if I press that button, right? So I have where I could go ahead, I could do a full face. That was easy for right here. If I do, whoops, I don't want to do that full face. I could do a full face like that on the edge of it, like that, right? Or let's just say I wanted to pick edges as I went around. I could do this, and I could follow it around like that with the red arrows. Everybody see this? Oops, my window's in my way. See how that works? So that would be the same thing. But so there's quicker ways to do stuff. Or I could go like this, loop, basically loops me real quick. So play around with this geometry selection as you start playing around with Mastercam. Does that sound good? Now, if you're not selecting off your solid model and you only have wireframe, you got to go to wireframe. But because we have a solid model, we're selecting solids right here. Does that make sense, everybody? You got any questions on this? No? So now what we're going to do, so since I picked the profile, I'm going to hit check mark. And this is the classic Mastercam toolpath windows. They look pretty much the same for all toolpaths, just the selection's different or the options are different. So looking at this, my toolpath type was already picked. Do I have to do anything, you think? No. My geometry was already picked. Do I have to do anything? No, but I could click on it again and see what I picked if I needed to edit it. So when I hit check mark there, basically I don't need to do anything here. I already did this by selecting the toolpath and the geometry on the first step. Is everybody good with that? Got any questions there?
Yeah, I have a question about the last part. When you were saying the wireframe, that's dependent on what you imported, correct? Like
right. So I'm going to show you some stuff, Ryan, in a little bit on how wireframe works, like at the end of this. Sound good? So, but right now, if I had just wireframe like geometry, like you saw in the PowerPoint, where it's just the outside profile, you would just pick that other icon instead of solids.
Okay.
Now, the tool is what we have to build next, right? So Max decided we wanted to do them here. So that's what we're doing. So when we build tools, what we got to do is we got to select tool library. We go over here. I'm going to hit filter. And I could pick none, and I could just pick face mill equal to 3. Or I could just pick, basically between a certain size if I wanted to. I could ignore. I could just hit check mark now. It shows me all the face mills they have built. I could build a brand new tool. But what I like to do is grab a tool that's already built about the same size and modify it. Does that make sense, everybody? Now, if you were running this for your own shop, you would go ahead and have a tool library and a tool list for your actual shop. So what I'm going to do is I'm going to pick the 3-inch face mill right here. I'm going to hit check mark, and I'm actually going to double click it real quick. This is how you build the geometry for this face mill. So our face mill's got a 3-inch diameter. Its secondary diameter is also 3-inch. Hold on, we gotta fix this. It doesn't have a chamfer on it. No, we'll leave that chamfer 0. So it doesn't have a chamfer, so the chamfer's 0. So we got a square shoulder 3-inch face mill. Is everybody good with that right there for now? Now, I don't care about the stuff above it. I could build a holder on it, but for right now, I'm not worried about that. I'm gonna go to next. I'll show you where you build a holder in a minute. This is gonna be our tool 1, right? And our tool 1, if we go back to the engineering drawing real quick, let me go back to the original slide. I just wanna show you where we're getting this data. So we're gonna run a 2,500 surface speed in feet per minute, and then a 4th thou inch per tooth chip load for this face mill. We're running kind of weak feeds and speeds. So back to Mastercam. If I run a SFM of 2,500, it calculates then the spindle RPM for me down here of 3183, right? And then if I run, it's a 4 flute, I run a 4th thou chip load, what am I gonna do to this 50.95, you think? 52. You know me by now, I think. So, and we're not gonna plunge with this face mill, so we're gonna run 52 for our plunge rate as well. So that sets up my tool number, my speeds and feeds. Fair enough? Any questions now at this point? So when I
Can spindle speeds not be decimals? And that's
no,
why
you can't have a decimal spindle speed. That's why I make whole number feed rates too, just because. So.
but feed rates can be decimals, correct?
Yeah, they definitely can.
Okay.
I never make them. I make them whole numbers. Because if you think about it, like an inch in a minute, it's not very big of a difference, right? So I round up to whole numbers. That's just me. I've been doing that for 20 years. So we hit finish. So now check this out. It grabs the speeds and feeds and the tool number and the diameter for that tool. Does that make sense, everybody? Now, if I wanted to build a holder, here's where I would build the holder right here. On this next slide, you could basically, you can grab a library, you could grab your CT40 holders because we have Cat 40s. And I don't know, I'm gonna make one that looks, I'm gonna say ours looks like that. It does not, but does that make sense? You can build whatever holder you have so you don't run into stuff. Does it matter with this part, you think? Not at all, right? But if we get into multi-axis stuff, it might matter and it will matter. And we'll talk about that when you get into that class, 336. So now we're going to talk about cut parameters. Now this menu here is cut parameters. What cut parameters is all about is how you're going to step over. Are you going to go one way? Are you going to zigzag both ways? Are you going to do one pass? How are you going to cut this part? So what I'm going to do is I'm going to just do zigzag. I'm going to go back and forth on it. Sound good? And then I'm going to go ahead and I'm going to roll around all corners. So I'm not making sharp direction changes with that. And I'm not going to leave any stock right there. Does everybody see this right here? The max step over. That's your width of cut for this face mill. So we're burying it at like 75%. That work. I'm going to do 2 inches. Fair enough. 66% for me. Now, read what they are. They pretty much are just overlap, how much it overlaps, how much it exits for the distance and so forth. So that kind of sets up how you're going to come across the part in the XY axes. Does that make sense, everybody? This is XY data, basically. Now, depth of cut, do we need to take this in multiple depths of cut? This 10 thou? No, but if we did, we would hit this button and fill that out with the roughing steps and the finish cuts. We'll do that when we get to our other projects. Sound good? So when I close that one off, I go to my linking parameters now. I've got this retract. So let me stop here. Depth of cut doesn't show you how deep you're going. It just breaks up your linking parameters. So the linking parameters are basically where you start and stop in your cut, and where you wrap it down to and where you pull out to. Does that make sense, everybody? So we are going to retract, and let me stop again. Now, these values are based off of two different ways. They're based off of absolute or. Now, absolute, what do you think that's based off of?
Your G54.
Yep, that's based off your G54. For right now, I'm gonna have you just pick absolute for everything. Incremental is based off of where the geometry you picked. So wherever the Z level of the geometry you picked, it'll move it incrementally off of that value. Right now, the geometry I picked and the absolute value are the same, aren't they? Because I picked the bottom of the part. Remember that? So but for you, for now, I want everybody to run absolute for right now. Sound good? So we're all going to run absolute until we get it figured out perfectly. So it's just going to be safer. So if I want to retract and basically wrap it down to 100th thou above my part, my stock's 0.5, what's my absolute value that I need to put in here?
Did that right?
It's 0.6 because it's the thickness of the part plus 100th thou.
Oh.
For absolute. So we'll have 0.6 right there. The top of my stock is 0.49. Let's say you didn't know all these numbers, everybody. Guess what you can do? Watch this. You can hit depth and you pick the top of the part. It's 0.49 absolute. Fair enough. So you can just go click on your part and it pulls these numbers up. We doing good? Cool. So that's basically setting up my overall depth. Now, last but not least, I like you to just double check that G54 WCS is your tool, your WCS, your tool, and your C plane. That's what we set up at the beginning. And if it doesn't show this, you didn't set up your planes right at the beginning. And you could change that by clicking this button and selecting the right one right here. Does that make sense? So if I knew I was supposed to be programming off the top, I could have went to top instead of that one and then just clicked over to top like that, but that's not right. I need to be at my WCS that I set up earlier, that right there. And then I just so that's just a sanity check that you have your construction, your tool, and your WCS planes appropriately set up. Fair enough? So you should never have to do anything in here, by the way. Now, last but not least, do you think we want coolant? Let's turn it on, and by default, it's off right there. So at this point, when I hit check mark, this is what it does. Is it made some blue lines and some yellow lines. I'm going to take F9 and turn it off so it's easier to see. Notice F9 toggles those, right, the axes. But this is my tool path right here. That's kind of cool, right? And I probably would have stepped over way less. So, right, but again, it's just kind of showing you how that works. So we've got to be able to simulate this now. So to simulate this, does everybody see right up here, we've got this back plot. There's my tool with my cool holder, right? I've never seen a holder that reduces like that. Kevin, have you? So that's weird, huh? So here we go. Let's press play. I'm going to make the machining noises, right? Those are bad ones. We're not very good at that. Does it look good so far?
Didn't you tell it to do the arcs instead of the sharp corners?
I thought I did. Let's go look. I thought I said roll around corners. I'll show you how it. So if I wanted to edit it, does everybody see this parameters? That's how you get back to that menu. You click on parameters. That brings you back to this menu right here. Should roll around. Oh, I think that is weird, huh? Oh, it'll roll in. We'll talk about rolling into cuts later. Yeah, I don't know why I didn't roll around the corners. So at this point, I'm just kind of curious what high-speed loops do. When I change that and I go to regenerate it, there it is. So there's our roll. So did everybody see what happens when I change it? Watch this real quick. Let's say you messed up something. And you're like, oh, I want to do like a bigger step over than that. You click on parameters, everybody. Let's say, oh, I wanted a 2.75 step over like before. So when I hit check mark, you see how it turned red. Something has changed. That's known as a dirty toolpath in Mastercam. So the toolpath is dirty. So there's this button right here that says regenerate all dirty operations. You see that? So when I click that, it regenerates the toolpath, and now we just save time, which is equal to money. Can't beat that. So we've basically shortened our toolpaths. And now, what questions do you have for me?
So Mastercam does not auto regenerate toolpaths when you change parameters.
No, it does not.
Okay.
That's kind of nice. I like that. So I like that. I like to be able to select when my computer's going to regenerate it. Because when I'm on really junky computers like you see behind me right here, last night I was programming something with a 5/64 end mill trichordal cutting. I would post the thing in HSM. I would walk away for 10, 12 minutes and be about 70% done when I came back.
Fair enough.
With these computers. So I don't, and I didn't want to do it every time I made a change. I only want to do it when I'm done, you know what I mean? When I'm done. So I'm just giving you why I like that. So here we go. So that's the face mill pass. Now there's one other way to simulate it in a 3D environment. Check this out. If I go to verify, does everybody see this verify? Now, what happens with verify, it pulls up a whole nother menu or a whole nother window, a verify window. Can you see that on the Zoom share? Cool. So so now it's cutting off of your virtual stock. Remember that you set up earlier? Ooh, my mouse is going to die. That won't be good. I hope it makes it. So we press play. There we go. That's what happens when you have a rechargeable mouse. And now we're at 0.74. That should take 26.67 seconds. We should be good. Sound good, everybody? How this works? So if I'm happy with that, I go back out here and I'm ready to create some more tool paths. What do you think? Got any questions?
What would have happened if you were to select the like top part that's already been profiled and whatnot to?
It would make it a little bit shorter, your face mill pass, because it would only profile that part. So your lead in better be long enough so you don't run into your part when you drop down, because it's a non-center cutter.
Okay, that makes sense. So the part that you're selecting there is more about the part that is trying to cut
size.
out.
What I've selected is my stock size. So yes, whatever you're selecting is what you want to cut. And with the face mill, I wanted to cut this entire 4x4 rectangle. So I've selected the bottom as the 4x4 rectangle. I could also go in here, Thomas, just to show you, instead of that loop, I could delete this one. I could right click, I could add, and I could have picked up here instead too. No different. So literally up there, when I regenerate, it's the same exact tool path. You see that? It just needed to know the XY geometry.
Okay, that makes sense.
Cool. So now what's kind of annoying is having tool paths in your way, right? So there's these blue squiggly lines right here. Does everybody see that? It toggles the lines on and off for your tool paths. Isn't that cool? So I'm going to keep this one off. And the next tool path we're going to do is going to be a contour tool path. We're going to contour around the outside edge of this part. So to do that, which tool path am I going to pick out of here? Contour. So I pick contour. Now, with this one, I'm going to take off select faces. So I took that one off. And I'm going to keep loop on. I'm going to pick that loop right there. Check mark. Now, let me show you something here. Let me press escape actually to get. Is everybody right here after you pick the outside loop? Now that we picked that outside loop, let me show you something. I'm going to go back and show it to you real quick. When I click on this geometry, does everybody see how the green arrow is on the inside? Do you think that's going to be good? Christian says no. So you're right. So right click, I could basically change side, and I could reverse direction and then change side. This is what you want. You know why? What type of milling do we do? Let me go back to that. What type of milling do we do normally in a CNC? Do we do climb or conventional?
Climb.
So you can see here, we're going around the part this way on the outside, right? If we're on this side and going that direction, we're climbing. You see that? Does that make sense? I hope so. No, can't, no, okay. So we're gonna go on, I'm gonna press check mark. Now, at this point, so I've selected my geometry of my part. I'm gonna hit tool. Should I use my 3-inch face mill to profile the thing? Probably not, right? So I'm gonna grab my tool library. I'm gonna go to my filter. I'm gonna select all, I'm actually gonna select none, and I'm just gonna pick end mills, flat end mills right now. And because I know what my size is, I'm gonna write equal to 0.5 right there, so I don't have to look through a bunch of different tools. So when I hit check mark, here's my 1/2-inch flat end mill. When I click on it, might as well just double click on, or I click on it and I double click right here, and I'm gonna build it. So I make sure it's a 1/2 inch. My length of cut is actually 1.5 inches on this one that I have. We'll put that value. I'm not too worried about the shoulder length and the shank diameter. They're the same. They're pretty good there. When I go to next, this is tool 2 though, right? And when I go to the PowerPoint, tool 2 is running a 750 surface speed. It's carbide, and it's running a 2 thou chip load, but I ended up having a 3 flute if you're gonna run this on your own. So when I go back to Mastercam, I'm gonna make this 750 surface speed, 3 thou chip load, or I'm thinking 3 flutes, and was it a 4 thou chip load, I think?
I think you said 3 before.
Oh, 2 on that one.
Oh,
So 2 on that one. So we're going real weak on that one. So we're gonna plunge down in, yeah. All right, so at this point, I get my 34. So I do like 36, we'll be fine. We're 9 millionths off, right? Right there for that chip load, that thickness of the chip is not gonna make a difference. So on plunge rates, does anybody remember what we do for plunging normally?
Half?
Sure, we're gonna do half. We're gonna do 18 for right now, half to 2/3. So to 3/4, depending on what you're doing. And then it's actually carbide, so we'll just fill it out appropriately. So I literally filled out the tool number, the surface speed, the chip load, and that gives me my feeds and speeds, right? So when I hit finish, this is a 1/2-inch flat end mill. I've got my feeds and speeds set up. I like to hit rapid retract. You might as well pull out as fast as you can, wrap it out. So when we've got that, we've got all of our feeds and speeds all set up. So I could put a holder on it. Should we put a holder on it? Nah, I'll just leave what it's got. Sound good? We'll put our cut parameters now. All right, so here we go. We talked about cutter compensation in class, didn't we? So we can do it 3 different ways. Oh, we can do it 4 different ways, technically. So we could do it with the computer. That's where the computer offsets it, the radius value of whatever's in that cut control menu in the previous menu. That's what we're gonna do for now. We could do control where it programs it to the exact geometry's dimensions, and then it offsets it the radius value in the control because you put the diameter in the offsets of the actual tool's diameter. Then we have where you have a 0 in for the diameter. It offsets it like computer and only adjusts a small amount, the wear value that you put into the actual cutter comp wear D value in the control. Then off will just follow on the line and not do any cutter comp at all. We're gonna use that for engraving stuff. So we're gonna pick computer. We wanna compensate to the left or the right based off those arrows to do climb milling. What do you think? What side of the line is climb milling, left or right? Left. Right? G41 is left, right? It stays on the left side of the line as climb milling. So what we're gonna comp to the tip, we're good there, and basically we'll basically roll around all corners. Oh, it already is gonna roll around all. There's no sharp corners anyway, so that's fine. and stock to leave on the walls. We're not going to leave any stock on the walls or the floors. Depth of cut. We actually don't need a depth of cut on this one, but I want to do one finish pass on the bottom. So if I go back and I look at my drawing right here, you're going to see the difference between 490 and basically 250 is what? 240, right? So we're going down 240. So when I come over here, if I go down 225 and I take one 15th thou pass, I'll be good. Does that make sense? So I have a rough and a finished pass on the floor. Now, lead in and lead outs are usually made pretty large by default. In fact, it's a 1/2 inch. So I'm going to make mine a 1/4 inch and a 1/4 inch. I'm going to make it half that size. And then you hit this button right here to shift it over. So this moves the data from this side to that side or vice versa, if you want to make them the same. Now, we won't worry about multi-passes yet. So don't worry about these other tabs that are great or that are blanked out. But we're going to go down to this linking parameters. We're going to set everything to absolute for right now. Now with absolute, I know that 0.6 is above my part. So I'm going to do 0.6 for my retract and my feed. Then my top of my stock now is 0.49. Let's say you didn't know this. You can come out here right there and it grabs it. Now my depth, let's say you didn't know it, come right back here. Whoops, I grabbed the bottom of the part. That won't be good. Right there. So it's 0.25 absolute. Incrementally, let's check this out. Let's just show you how incremental works. Incrementally, I think it's 0. If I remember what I selected. Incremental, it's 0. And then this one incremental is 0.24. Does that make sense? Because I picked the geometry incrementals based off the geometry you picked. But for now, everybody's going to program an absolute for our first project just because it makes, I think it makes more sense to you, maybe. Maybe it doesn't. Does that make sense, everybody, how that works? So when I go over here, I just double check my planes are good and my coolant's good. And then I press check mark. What that does is it drops in and it brings the end mill around, cuts the part. Now, if you were worried about this extra little bit of material here, it's not a big deal for this part, but you could go to parameters. You could go right over here to this multi-passes, and you could have 2 at 100 thou. And what that does now, do you see how it spaces it out about that contour? So it starts on the outside and works its way in a little bit more, right? But we don't need to worry about that. So if I go to parameters, there we go. 1 second. My computer's not happy right now.
Turn your camera off. It'll be happier.
There we go. No, I'm gonna tax it. So we go check mark, and then we go to refresh. There we go. Now it's happy again. So basically, we got this around the part. So if I wanted to simulate this, everybody, you highlight the entire setup, you hit this verify, you hit play, and it made the part. Good so far?
Where's the option to slow that down? It all kind
Oh,
of
yeah. So to verify it and slow it down, so we're going to go back and verify. It's right here, slow fast. So what it shows, it's on your graphic, it shows blocks. It doesn't actually, it shows you a cut and like block by block. See how it's kind of chunky? So yeah, it could be graphics card, it could be memory resources and stuff like that. Now, what I would recommend if you really wanted to see where it's going on your part, Kevin, probably this one instead, this back plot on your part. It's a lot slower and a little bit more methodical, right? That's probably what I would use. Cool. Give me a thumbs up. I'm off with that. So what do I got to do now to go ahead and do this one? What type of tool path? Pocket. I think that's what Thomas was going to say, right?
Yeah.
Cool. So I'm going to go over here. I'm going to go to pocket. Now with pocket, I want that one. And I also, so does that make sense so far? I want that. Now, I also am going to want what? Something else in this pocket. Anybody know?
The boss.
I want that as well. So just do that one. In chain. Cool. So when I pick that, we check mark it. We check mark it. I've got that pocket now. And does my tool change from this 1/2 inch flat? No. So I'm not going to do anything other than click rapid retract just so it pulls out in rapid. Now, when I come to my cut parameters, if I wanted to leave stock on the walls and the floor for another tool, I could do that right here off the geometry. I'm not going to worry about that. I'm literally just going to pocket down into the part. I'm going to climb mill in my pocket. I'm going to just do a standard pocket. Right here, I can choose my roughing routine. I could zigzag. I like to do a true spiral off the thing. Ryan.
For that leaving material, is that for like if you're boring or reaming something after? Or
Not necessarily there. Let's say you know that you're just roughing really hard and big depths of cut. You leave like 10, so you don't do it in the linking, you leave it right there, so it will leave it on that surface. Does that make sense?
yeah.
You can pick that surface in the linking, but it'll still leave that material so on that surface. So you can come back with a sharper tool, maybe a finishing tool, and runs maybe a reduce your feed, bump your speed, something like that, and then get a nicer surface finish.
Okay.
Or Ryan, for like other operations, like grinding operations, if you're going to grind it afterwards, you leave a little stock to do some surface grinding afterwards. Cool.
It makes sense. Thank you.
Yeah, you're welcome. So that sets all that up. The roughing, I'm going to just do true spiral. It's bad to actually step over exactly at 50%. We'll learn why later. So I'm going to do 40 for right now. 40 or 60, whichever one you want to do. Now, do we just drill down with our end mills? Do we just plunge straight down with end mills down to the depth? No, what do we do? If I turn it off, it will, right? If I turn ramp on, it'll do zigzags down, but we want to do a little helix down in. And then I'm going to make the helix 0.25 to 0.125. It figures out the maximum between the max and the min to make the radius.
When would you want to ramp?
Big radius. Was there a question?
Yeah. When would you want to ramp? Is there like a
If you
specific-
can't get into it with the helix, you would ramp.
Okay.
Like if you have a slot, you ramp down into your slot.
Okay.
So I like to plunge at 2 degrees because that makes me able to run a faster plunge rate. I can run like 75% a lot of the times of my feed rate. Now this is what gets everybody a lot of the times is everybody see entry feed rate could either be feed or plunge. What do you think the helix should be? Plunge rate. We're gonna run the plunge for our helix. Sound good? So that's literally the entry motion. Now, if I wanted to finish pass on the walls, I could do that. So right now it's going to do a 10 thou finish pass on the walls. On the lead in and lead outs, this is for your finish pass. So I'm going to make it a little bit smaller. Now, if I wanted to finish pass on the bottom, I could do that too. So if I go back to my drawing, I see that the bottom is 190 minus the 115, right? So we basically have that 375 right there, 385, 375. So we have the 375 to go down, right? So coming back here, I'm going to go down 0.365 and this do 110 thou finishing pass on the bottom. Sound good? We'll go down 360 and do 15 to match the last one. So that sets it at the bottom. The linking is where it's all about, right? So if I go absolute, 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 these are all my depths. We do 0.6, 0.6, 0.49 is the top. The depth comes down to here, right there, 0.115. Got any questions for me at this point? So when I come back out over here now to my planes, I just double check my planes are the same. Nothing's changed. They should never change. For now on this project, we go to coolant, we go to on, we hit check mark, and it basically makes my tool path. Now, do you see how big these do you see how big these lead in and lead outs are for the finish pass, everybody? We have one here and one here. Those are horrible, if you ask me. So what I do is I come back in here to my pocket and I go to my lead in and lead outs. I'll make them really small. All they got to do is keep the tool away from the wall. So that's all you're doing really right there in those lead in and lead out. So now notice I have really small arcs in there, right? For those finish passes. So what it does is it helixes down. We'll go watch it real quick. So what it does is it's going to, we're going to go to slow. Ooh, maybe we'll go faster than that. You'll see, this is what it does. This is what it does. I'll give it a second. Now it's going to helix in. That's now its finish pass, right? It's working on its finish pass, the last little 10 thou there on the floor.
That doesn't look right.
It's not done yet.
Okay.
Would you be able to show how to get into this simulation view again real fast?
Yeah, no problem. Give me a second.
Thank you.
Yeah, so there we go. So that's the part, right? At the moment, we're not going to chamfer this part. Now to get into simulation view, you need to highlight everything. Just so you know, if you highlight just that and press simulation up here, which is that one, verify, you'll only verify that one tool path. So they all need to have green checks on them. And then you hit this verify. That brings me into this 3D menu or this other window, and now it's done. Cool. I didn't see who asked that, but I think we're good. So now that we got.
Quick question. Are those internal radii, are those the same radius as the tool, or are they slightly greater?
They're greater. That would be that's bad design. So you see interplates right there. See that?
Yeah.
It interplates to the corner. So next we have, I'm going to hide this tool path. Actually, that one, I'm going to hide the middle one. What do we got left to do?
Holes.
Yeah, we're going to make some holes. The most common way to make a hole is a drill bit. So we're going to go grab the drilling tool path. So we're going to grab drill right here. Now, what do you think I pick? The holes. You got this, right? So there's that one, that one. You can reorder them. I'm just going to go like that. Does everybody see right here? We got our features. We good there? So we hit check mark once we pick all of our circles. And now I could go to my tool. I'm going to go to filter. I'm just going to pick drills. 1/4 inch drill equal to 0.25. So, ooh, they don't have any of that. There are no drills. That's pretty crazy. So when there's no tools, oh, it's my computer, right? Because it's the Zoom and it's having trouble. I found my drill. Everybody else find the 1/4 inch drill? It's tool 124. I don't know why mine did that. It's just, it has to do with the internet and everything we're doing here. We're running a lot of stuff at once. So we're going to go to tool number 3. Now drills, if you didn't want to sit there and build the table for the surface speed, if you look right here on the PowerPoint, we're going to run a 450 feet per minute drill and a 3 thou inch per rep, real light on this drill. So really .003, and then 450. You know what? Let me just double check on the drill real quick. I wonder if it has, let me go here next. So when we look at this, it's feet per tooth. So it has 2 flutes, just making sure it had that calculation correct. That's all. So I'm gonna just build it right here, 450. And then tooth thou chip load, I'm gonna do 28. Anybody got any questions? We good there, everybody? So we're going to, it doesn't have rapid retract as drills are can cycles. It's gonna wrap it automatically. I'm not too worried about the stock right here. Here's your cut parameters. What does this post in order to do a drill routine?
Can you repeat that?
What does this post to do a drill routine?
Can cycle.
A can cycle, right? So basically you have a can cycle and you can pick between your different can cycles. So a drill is a G81. We got our pec drill. We're going to do a G83 pec drill. Tap is the G84. If you remember, we're going to do G83 pec drill. We're going to pec basically 1/4 inch increments through our plate, 2 pecs. Sound good? Look, it's done. Now, with that drill and the linking parameters here, if I just pick 0.6 to retract absolute above my part, right? Then the top of my stock absolute is right here, 0.49. My depth absolute is through the bottom. What's the problem with that being at 0?
You're not fully breaking through.
Right, drill bits have a point angle of 118 degrees or 135 degrees. So you hit this little calculator right here, and based off the drill bit's geometry right there, it needs to add that 75 thou to it. You see that? So add to depth, check mark it, it'll add the tip depth. Now, what do you think I do to this number? I make it 80 thou. Fair enough. So nice round numbers. You know you've changed them at that point, right? So, because that doesn't matter. The millisecond that took to go the extra 5 thou, not a big deal, right? So last sanity check, planes, coolant. We go to on, we check mark it. We got our drills coming down through the bottom of the part. Is everybody good? So that's really those are really 4 basic tool paths in Mastercam. So I can simulate all that by verifying it. We'll verify that real quick. Looks good to me. You happy? So with this, you got all sorts of stuff in here. With your verify, check this out. You can save your stock as STL as well and 3D print it. Nah, we're gonna go make it for real instead of a 3D printer, right? So we'll go ahead, close that out. Now, if you're happy with all this code, what do you need to do to get it onto the machine?
Download it onto a flash drive.
We got to get the code first by post-processing it and then download it on the flash drive. You're right, Ryan. We got to post-process it. So in order to post-process it, by the way, don't hit the dynamite. That destroys all your tool paths. You can hit the dynamite. It just deletes everything. But you're going to hit the G1 next to the dynamite. Fair enough? So when I hit G1, it saves it by default as an NC file. When I hit check mark, that's a native CNC file. I'm just going to throw mine on the desktop. Sound good? Mastercam demo.nc. When I hit save,
For the drill, all of those linking parameters, those measurements were to the tip of the drill, correct?
yep.
Okay.
All right. So right now we're going to call this 335. And I like to just delete those long comments. I don't care about where my file path is for that file. But check this out. Oh, it does. We'll fix this later. It does post an A value for that one. We can turn that off in the post. I'll show you how to do that a little bit later. But that's the only thing. But check this out. Other than that, These are the default commands getting it ready. You see that G17 plane, it cancels cutter comp. It basically cancels offsets. And then it goes and does cancels can cycles and then puts it in absolute. But you know, T1M6, how that works, right? Tool changes. There's your startup lines right there, right? It does it with we're going to get rid of the A0 just to show you. These are the 3 startup lines or 4 that you should have answered on the test, right? Or you should have been able to explain what all that does. Does everybody see how that works? How we've learned how to do all this? And then once we wrap it above the part, we feed down to the right height. We come across, we do a GO2, GO3, it wraps up. This one just turns off the spindle and returns the Z home and basically puts an optional stop. But this stuff, actually, you could delete that and not even need it. You know what I mean? Between the tool changes. So literally, that's how that works. And you've now done it manually. We're going to start learning CAD CAM and how Mastercam works here. So moving back to our PowerPoint presentation for the day, what questions do you have about that programming before we go to anywhere else, do anything else? And again, this is all recorded. I'm going to put it on my YouTube channel. You can check it out. It'll stay there forever too, because I'm going to just put it as a link there for you, so you can grab it and relearn Mastercam at any time if you wanted to. Sound good?
So when I hit the G1 button, it said that feature wasn't available in the home learning edition.
That's right. You can't make code with the home learning edition, so you can do everything up to that point. So you're gonna program everything on that home learning edition, and then you're gonna come into the computer lab right here, our Mastercam computer lab, and you're gonna post your code in this lab. We have an academic license in this lab of 48 seats, so you can literally be in here and post your code from your home learning edition.
Okay, yeah.
All right. So, any other questions?
Is there any way to like define fixtures or milling devices to make sure you don't crash tools and stuff like that?
There definitely is, and we'll get into that at some point in the class. But yeah, we can definitely add on our stock setups. We can add it. Yes, we can add a fixture in there, not on the stock setup right there, but no problems on that.
Okay, cool. Thanks.
Yep. So anybody else?
Does that mean that since we can't post-process on the home learning edition, we have to redo like everything that we did when we come into lab, or is there a way to like transfer all the work that we've done?
Can anybody answer that? Can anybody else answer that real quick?
Just going to load your Mastercam file on one of the lab computers, and you can post from there.
Thank you, Kevin. So at this point, what we're going to do is we're going to jump over to right here. So we're in the middle of our business card holder job, right? So far, everybody had to have their CNC code approved by the end of today's lab, which I'll have a little bit of time if you need to get approved still. And then, so we're done with CNC Op 1. We're done with Op 1 fair inspection. So we're jumping on to CNC Op 2 right here, right? So we can't really program CNC Op 2 by hand in the 3 weeks you're going to get to make this part from start to finish. So we're going to jump into Mastercam and make it there. And part of your job for this is you're now going to be the programmer, right? So you're going to need to create a good program for your technician to run, but you're going to be the engineer and the technician on this job. So you're going to document basically and create your CAM program. And with that CAM program, you're going to be machining this part right here. And, we're fine. So you're going to be making this part right here. I put the model up for you on Canvas. So in order for you to make this part, you need an engineering drawing, right? So you need to personalize the part where it doesn't say your name here. And after you personalize the part, you then can make this drawing, and then that's going to be your homework assignment number 6. So we are going to add a little bit more GD&T to this drawing that we had on top of our op number 1 drawing. So from op number 1, if you think about it, we checked this parallelism to the C datum, right? We checked the B datum and the parallelism to the B datum, right? What else did we check? We checked the flatness. But now we didn't have an A datum before on the project because we didn't have anything to compare it to. But we're going to locate the part on the A datum, and we're going to compare how parallel we got this bottom pocket to the A datum when we machine it too. Fair enough so far? So we're going to do that. We'll end up inspecting this thing on a CMM. We'll program the Zeiss CMM that we have to inspect this. But let me clear that real quick. But where would a good 0 point be for this part based off those datums?
Back left, bottom corner.
Yeah,
Seems
so
like
we're gonna go off the bottom for the Z, right? The A datum for the Z. We're gonna go off basically the top right there for the secondary datum. So we're gonna put that in the fixed vise right there, jaw, right? And then we're gonna build a little jaw that has a stop. We're gonna just cut a little soft jaw to tertiary datum to stop us here on the C datum. Fair enough, everybody? So everybody's gonna have the same XYZ0 based off the part datums at this point. Now, once you personalize your part, let me go up here and clear the drawings. Once you personalize that part, you're going to then make the engineering drawing and save it as a PDF and turn that in on Canvas by the start of lab number 6. So you basically have 1 week from right now to go ahead and get this drawing done. And that's what lab's about today, is to work on this. That's what lab's all about, the remainder hour of lab. So to do that, before we get into program planning, I just want to show you real quick. This is what we got. And in order to get your name here, you are going to delete that by pressing delete on it. And you can delete that sketch. Fair enough? So if you want to go ahead and put your name on it, I just want to make sure everybody's in the same boat here. We're going to go to features. We're going to go to a cut. We're going to cut on that face right there. Space bar, normal to it. And you're literally just going to use the text tool to write whatever you want. Fair enough. Now, when I hit font, I can pick any Windows font I want. Ooh, where's freshman font? There we go. There's college font, right? So I can go ahead and put whatever I want on there. I can line it up. Sound good? I can check mark it. When I exit my sketch, I'm going to go down 2 thou for this engraving. Sound good, everybody? You're only going to engrave 2 thou deep into your part. And you're going to end up then with some sort of personalized part. Now you have 2 of these. Now, if you personalize 2, that's cool. It's really easy after you program 1 just to engrave the second one in Mastercam. I'm going to show you that later on. So if you have 2, personalize them and go ahead and make 2, but only turn in 1 for homework at this moment. Sound good? Now, let's say you didn't want to go ahead and have Cal Poly all over your business card holder. Maybe you're going to the Coast Guard or something. I want to write Coast Guard symbol on it. Who knows, right? So what you could do is you could erase that easily. Well, you could go back and delete the cutouts if you want, right? You could either delete my cutouts. That's probably what I would do. I'd probably just delete the cutout. Let's just go that way. I was going to show you could extrude over it and then cut it out, or you could just go delete it. But you could make it say whatever you want as long as it's school appropriate and we're being respectful. Sound good? So that's what your job now is, to use that SolidWorks model and basically make this part right here. Sound good? You have the entire part other than that. Now, what questions do you have about homework assignment number 6? Nobody? So once you get that down, we're then going to meet next week in lab, and I'm going to go through programming 100%. I'm basically going to give you a fire hose in the face of Mastercam programming. So you should start practicing with Mastercam over the next week and looking at it a little bit. Sound good? And we're going to program this from start to finish here. But I wanted to take a few minutes for you to jump out into your breakout groups, and I want to know what we need to do to go from the operation number 1 to op number 2. So tell me exactly what we need to do to go to op number 1 to op number 2. We're going to jump into breakout rooms. Let me assign, or do you want to do this together? Would you rather do it together?
Together.
Together? All right, let's do it together. Cool. So to go from op 1 to op 2, what do we first need to do? Does anybody know? We're going to put the part in the machine and it's got that material that it's sitting on, right? So what would be a good idea? Yep, there's Kevin's face mill sign, right? So I would say our first step would be to face mill off the material. Let me go in over here. Oh, look at this. So the first thing we're going to do is we're going to make some planes and some chamfers. We're going to face mill off the extra material. That looks good, huh? So the top now becomes the bottom, right, from last time? At this point, what do you think we're going to do?
Plunge.
We're going to helical plunge into our part and we're going to pocket it, right? So we're going to create, it's not going to go all the way down like that, by the way. We're going to create a pocket that looks like, not with that. We're going to create basically a pocket that goes, let me just get you to that point right here. We're going to create a pocket that stops right here and it's at the full depth. And we're going to leave this material here to come down and ramp with an end mill. Does that sound good? So after we do that, after we pocket it, what do we have to do after that? We have to create the ramp. Do you agree? We have to machine this ramp right here. Now, then we have to engrave it. Whatever engravings we put on the thing. There we go. Engrave it, and then we chamfer it right there. So that's literally the order of operations we're going to end up doing for this part. Now to do this, I've got a couple tools that we're going to use. We're going to use tool 1, 2, 3, 4, 5, and 6. Tool 1 and 3 are the same from before. So you're going to be given all of the surface speeds and the chip loads to run this part. So you don't have to worry about calculating feeds and speeds anymore. But what we're going to end up doing is we're going to face off extra material with tool 1, the 3-inch face mill. We're going to rough the upper keyway pocket with tool 4, which is a 1/2-inch 3 fluid end mill. Then we're going to rough the lower card pocket as well. I'll show you what I mean next week when we program this. Then we're going to take the 3/4 inch end mill and just full slot cut with the 3/4 inch and make that ramp with the thing. At that point, we are going to go ahead and grab a 1/4 inch 3 flute and do bad design and go ahead and cut those 1/8 inch radii with our 1/4 inch end mill. So we're going to do sharp corner changes in there, but it'll work. 3 flute, it won't chatter too bad. You'll see, we'll be okay. So we're going to do that. We're going to contour it. We're then going to basically chamfer the outside and inside pocket. And we're going to engrave the Cal Poly logo and name right there on that contour tool path. So that's going to be the steps that we're going to do next week. And we're going to do that basically, report, it shouldn't have been Friday. The report was, you know when the reports do. But that's going to be the major steps that we're going to do next week in lab. But I need you to have a model ready to go. And I need you to have Mastercam loaded and maybe have practiced a tad bit to be ready to go for next week for CAD/CAM programming lab. Sound good? And next week in class, we're going to get into some other stuff. We're going to get into some other material for CNC. So that's pretty much all I had for today's lab in terms of content. So now it's going to be open lab for you to work on Mastercam programs, or I'm sorry, SolidWorks models, and get your homework assignment 6 done. Work on project or homework assignment 5, your first article inspection, getting that in. There might be 1 or 2 of you that need your code approved out so you can get it done by 5 o'clock tomorrow, but 5 o'clock tomorrow is the deadline. So definitely, I'm going to stop recording at this point. So I'm going to stop sharing, stop recording.